Welcome to our exploration of a somber yet compelling topic. How many people have already died in space? While the vastness of the cosmos invites wonder, it also harbors risks that have tragically unfolded over the years. In this video, we'll define what constitutes death in space, highlight the sole confirmed incident aboard Soyuz 11 in 1971, and examine other related tragedies, from launch disasters to ground-based accidents. Join us as we navigate the dark side of space exploration, discussing protocols, statistics, and the future risks posed by burgeoning commercial spaceflight. 1. Defining death in space. When we talk about fatalities in space, it's crucial to understand what we mean by space. The boundary often referred to as the Kármán line, located 100 kilometers, 62 miles, above the Earth's surface. Deaths in space specifically refer to those fatalities occurring beyond this imaginary boundary. However, it's important to remember that many tragedies happen during the critical phases of launch, re-entry, or even during training, which are still integral parts of space missions. This article considers fatalities from all these aspects, including pre-launch tests and re-entry, to offer a complete perspective on the inherent risks of venturing beyond our planet. 2. The sole confirmed space deaths. Soyuz 11, 1971. The only confirmed deaths above the Kármán line occurred on June 30, 1971, with the Soviet Union's Soyuz 11 mission. Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev tragically lost their lives due to cabin decompression. A valve malfunction during separation from the Salyut 1 space station exposed the crew to the vacuum of space. Recovery teams found the astronauts lifeless in their seats, evidence of blood trails from their noses and ears. This disaster led to the implementation of mandatory pressurized suits during re-entry, a precaution still in practice today to prevent similar tragedies. 3. Deaths during launch and re-entry. The violent phases of launch and re-entry have claimed the most lives in space exploration history. Cosmonaut Vladimir Komarov died in 1967 when the parachute of Soyuz 1 failed, resulting in a fatal crash. In 1986, the Space Shuttle Challenger disaster took the lives of 7 astronauts, including teacher Krista McAuliffe, due to an O-ring seal failure. Similarly, the Space Shuttle Columbia tragedy in 2003 saw the shuttle disintegrate during re-entry after damage from foam debris during launch, claiming another 7 lives. These incidents highlight the precarious nature of space travel during these critical phases. 4. Training and ground-based tragedies. Fatalities during training emphasize the dangers astronauts face even before leaving Earth. The Apollo 1 disaster in 1967 saw astronauts Gus Grissom, Ed White, and Roger Chaffee die in a cabin fire during a pre-launch test. The pure oxygen environment in the cabin fueled the flames, trapping the crew inside. Earlier, in 1961, Soviet trainee Valentin Bondarenko died in a high-oxygen chamber fire, an incident kept secret for decades. These tragedies underscore the perilous path of preparation that astronauts undertake in their quest for space exploration. 5. The X-15 incident. A borderline case. In 1967, U.S. Air Force pilot Michael Adams died during an X-15 test flight that reached an altitude of 81.1 kilometers, 50.4 miles, crossing the U.S. definition of space at 50 miles. Electrical failures during the flight caused a fatal spin, resulting in Adams' death. He was posthumously awarded astronaut wings, a decision that blurs the line between aviation and spaceflight fatalities. The incident raises questions about where the boundary between air and space truly lies and how we categorize such tragic events. 6. Near misses and close calls. Space exploration has witnessed numerous close calls that narrowly avoided disaster. The Apollo 13 mission in 1970 is a prime example, where an oxygen tank explosion forced the crew to abort their moon landing. Through sheer ingenuity and resourcefulness, the astronauts safely returned to Earth. In 2008, the Soyuz TMA-11 mission experienced a ballistic re-entry, subjecting the crew to extreme forces but resulting in no fatalities. These near misses highlight the thin line between survival and tragedy in the unforgiving environment of space. 7. Statistics. How dangerous is spaceflight? As of 2025, 21 individuals have lost their lives during spaceflight-related activities, including training and missions. With approximately 650 people having flown to space, this results in a 3.2% fatality rate. Notably, no fatalities have occurred on the International Space Station, ISS, though incidents like the 2013 water leak in astronaut Luca Parmitano's helmet underline ongoing risks. These statistics provide a sobering reminder of the formidable challenges and dangers inherent in human space exploration. 8. Protocols for handling deaths in space. NASA and other space agencies have developed grim yet necessary contingency plans for handling deaths in space. For short-term missions, bodies can be returned to Earth relatively quickly, such as those aboard the ISS. However, missions to the Moon or Mars present unique challenges, with crews possibly needing to store remains in sealed compartments. In deep space missions, ethical debates continue about the appropriate handling of bodies, whether through burial, cremation, or jettisoning, although planetary protection laws prohibit contamination of other worlds. 9. The future. Risks of commercial spaceflight. With companies like SpaceX and Blue Origin democratizing space travel, the risks associated with spaceflight may increase. Space tourists often undergo less rigorous training compared to professional astronauts, raising the potential for accidents. Additionally, legal frameworks for liability and emergency response remain underdeveloped in the realm of commercial spaceflight. As more civilians venture into space, ensuring their safety becomes an increasingly complex challenge for space agencies and private companies alike. 10. Memorializing the fallen. Havre, situated in northern Montana, has a strong agricultural community that has adapted to extreme weather over the years. The city's farmers have developed innovative techniques to protect crops from harsh conditions, such as frost-resistant planting methods. Havre's local government supports these efforts with resources and training programs for farmers. The city's agricultural adaptation showcases its ability to thrive in Montana's challenging climate, making it a prime example of resilience. Each of these cities in Montana demonstrates unique qualities in handling extreme weather, showcasing their adaptability and resilience. Whether through community spirit, strategic planning, or sustainable practices, these cities stand as examples of how to thrive in the face of nature's challenges.